Hello everyone and welcome to Sine of our time. My name is Bruce and I want to show you a shortcut for factoring higher degree polynomials such as cubic polynomials, which is going to save you a whole lot of time and make your life a whole lot easier sometimes. This method for factoring is called factoring by grouping, and I'm going to show you exactly how to use it. Let's consider this first example where we are asked to fully factor x cubed minus 7x squared minus 4x plus 28. Now, in order to use factoring by grouping, there are two conditions that need to be met. The first is that the cubic polynomial must have 4 terms and each of the terms must have a different degree of x, which is the case in this example. The second condition is that the ratio of the coefficients of the first two terms must be equal to the ratio of the coefficients of the last two terms. In this example, we have plus 1 divided by negative 7, which simplifies to negative 1 over 7. And then we have negative 4 divided by positive 28, which also simplifies to negative 1 over 7. And since these ratios are the same, it tells us that we can factor this polynomial using grouping. We can do this by grouping the first two terms and the last two terms and factoring them separately. For the first two terms, we can take out a common factor of x squared, leaving us with x minus 7. And for the last two terms, we can take out a common factor of negative 4, leaving us with x minus 7. To double check our work, we can take that negative 4 and multiply it by x minus 7 to see whether it gives us the original terms of minus 4x plus 28 in the polynomial, which it does. Notice that the expressions inside each of the brackets or parentheses are the same, which is exactly what we want and what we need in order for this method to work. At this stage, we now have two terms, and that x minus 7 is a common factor of each of those terms. So what we can do now is take out a common factor of x minus 7, leaving us with x squared minus 4. At this stage, it may appear as if we have fully factored this polynomial. However, we have not, since x squared minus 4 is a difference of squares that can be further factored to give us x plus 2 multiplied by x minus 2, and only now is this polynomial fully factored. But do you see how easy this is? If we really wanted to, we could factor this polynomial by using a combination of the integral zero theorem, the factor theorem, synthetic division, and factoring a quadratic, which would ultimately give us the fully factored form of this polynomial. But why? Why use all of that brain power and use so much time using this complicated process to get the answer when we can simply use factoring by grouping? Okay, so we have seen that grouping can be used to factor a cubic polynomial where the leading coefficient is equal to 1. But can grouping be used to factor a cubic polynomial where the leading coefficient is not equal to 1? Well, the answer is yes. Yes, it can, but only if those conditions are met. In this example, we are asked to fully factor a cubic polynomial where the leading coefficient is equal to 3. Well, no problem. Let's just check that those conditions are met though. The first condition is that the cubic polynomial must contain 4 terms, each with a different degree of x, which is the case. And the second condition is that the ratio of the first two terms of the polynomial must be equal to the ratio of the last two terms of the polynomial. In this case, for the first two terms, we have plus 3 divided by plus 2, which is equal to positive 3 over 2. And for the last two terms, we have negative 27 divided by negative 18, which also gives us positive 3 over 2. And since these two ratios are the same, it tells us that we can factor this polynomial using grouping. To do this, let's group the first two terms and the last two terms and factor them separately. In the first two terms, we can take out a common factor of x squared, leaving us with 3x plus 2. And in the last two terms, we could take out a common factor of negative 9, again leaving us with 3x plus 2. If we want to do a little check to make sure that we have factored correctly, negative 9 multiplied by 3x does give us negative 27x, and negative 9 multiplied by positive 2 does give us negative 18. At this stage, we notice that the expression inside each set of brackets or parentheses is the same, meaning that we are on the right track where we can take out a common factor of 3x plus 2, leaving us with x squared minus 9. And don't be fooled by thinking that we are done with the factoring, because we are not, since x squared minus 9 is a difference of squares that can further factor to give us x plus 3 multiplied by x minus 3. At which stage we have now only fully factored this polynomial. Isn't factoring by grouping just the best? If we really wanted to, we could use the alternative method by using a combination of the rational zero theorem, the factor theorem, synthetic division, and factoring a quadratic before we get the fully factored form of this polynomial. But why? Why use so much time and brain power and effort and energy where we increase our chances of making a mistake along the way when we can simply use factoring by grouping? So my advice before you start factoring any polynomial is to perform that quick and simple check to see whether that polynomial meets those two conditions needed to factor by grouping. Well, I hope that you found this video useful and that it equips you with a secret weapon that you can use to factor certain polynomials. Why not put your skills to the test and try out this problem where you can let me know what your answer is in the comments below. And if you'd like to further support me and my work on Patreon, then please click on the link in the description below to learn more. Well, that's all from me, and I'd like to say a very big thank you for watching.